All right, welcome everybody to today's presentation. First of all, a few notes to let everybody know. You're all on mute, so at the end of the presentation when I do open it up for questions, please feel free to type them in to the questions area in your GoToMeeting interface there on the right-hand side of your screen. What we're going to do is I'm going to start off with a brief PowerPoint presentation, followed by an actual demonstration of our software, Inertia 360. So let me begin. Thank you very much again for everyone for joining us today. This presentation is about Inertia 360, a software developed by Mechanica Solutions. The software is a mass distribution, weight, and center of gravity application tool for CATIA V5. My name is Peter Jarkowitz. I'm an applications engineer with Mechanica Solutions. Currently in practice today using CATIA V5 to obtain mass properties calculations from parts and assemblies. We're all familiar, if you know CATIA V5, we're all familiar with this interface we're looking at right here. Currently it's very time consuming and it's a manual process right now to extract mass property information from a product structure within CATIA V5. If a part is missing or a material density is undefined, you'll see that CATIA automatically applies a default density of, in this case, 1,000 kilograms per meters cubed. Using this practice, of course, you need to know how to use CATIA V5 to be able to open up the software, open up an assembly, and actually extract that information from the V5 model. Our solution, Inertia 360, originally developed for CATIA V4, currently available for CATIA V5, versions R16 all the way up to R21. Our software, Inertia 360, automatically extracts volume, mass, center of gravity, and inertia for each part and assembly in a CATIA solid model. I'll go over this in my presentation shortly. We generate weight and mass calculations as well as center of gravity reports, orders of magnitude faster than traditional methods. We also have the ability to use difference reports to evaluate trends with spreadsheet reports, which you can save locally and pass those around within your company. Use those to track history of difference reports. And we're also fully compliant with CATIA V5 and SQL database systems. A few of the features of Inertia 360, I mentioned a couple of these already. We extract mass properties data from CATIA V5 solid models. We allow the user to make changes to mass properties with or without affecting these properties in the original CATIA models. So for example, when we do an analysis, our software does indicate the densities and their values for each of the parts that we're analyzing. You're also free to make changes to those densities, and at the same time you can apply those back to the CATIA V5 part or choose to simply apply that current change for that current run of the analysis and then disregard that upon next analysis. We also create volume sections that are user-definable and easily changed. So I'll show you in my presentation how we take a volume model, and the volume model finds all the intersecting parts within that section and does mass property calculations for that particular volume, giving you the center of gravity, moment of inertia, etc. We extract those mass properties from those newly created volumes. We create accurate weight and mass distribution reports, which we can save locally. We can also store into a database of some kind. We produce mass properties reports for 3 levels of the structure: about each cut part's center of gravity, about each grid's section center of gravity, and about the overall structure center of gravity. And you'll see this again in my presentation. And then finally, we store the results of each run where you're able to compare them for future and historical trending. Again, the report types that we create: material and weight report and a mass distribution report. The interface of Inertia 360 looks like this. I'll go over all these icons when I get into the actual product demonstration. The ability to modify the settings, to point to a materials file which stores all the densities applied to the CATIA V5 parts, the weight report, and the mass distribution interface. Here is simply a sample of the weight report interface, again, which I'll go over in my presentation. very easily, icon driven, just fill in the blanks, have it automatically execute and run CATIA V5 in the background. And of course, the advantage of our software is that you do not need to be a CATIA V5 user in order to extract this information from CATIA V5. An example of the materials report that we generate, you can see on the left-hand side all the components. Again, this interface is customizable. All we simply do is extract the information generated by CATIA V5, and every customer that we deal with wants to see different information in their materials report. So in this example here, you can see that we've extracted the materials, density, volume, surface area, and then at the very end the mass of each of those parts. You'll also notice that, like I mentioned before, if a material or a part has an undefined material, CATIA then gives it that default density in order to compute the mass properties. And this will of course give you incorrect results. Our software does indicate the fact that a component has an undefined material, allowing you to then at that point apply a material to that part, run it to find your appropriate solution, and at the same time you can push that back to the V5 part and save that newly defined material to that CATIA V5 part. The mass distribution report interface, again icon driven, simply fill in the blanks and generate your reports. An example here of the volume model. Now I'll go over this again in my presentation, but basically what you see there is the volume model, and what we do is we compare the two, basically your finished assembly with this specific volume model. And what our software does is it creates, takes all the parts that cross into each one of those volumes and does mass distribution reporting for that particular volume. You can run it for the entire volume model. So in this case it looks like there may be about 75 volume sections. You can run it on all the volume sections, or you can simply focus on a particular area. So you can set possibly sections 1 to 5 and have the software do the calculation for a particular area of the assembly. What we're looking at here is an example of one of the clipped volumes. So if you refer back to the slide I just showed you, this is volume number 93. So what you're looking at is all the parts that cross into that volume, and our software has then taken a chunk of that assembly and it's done mass property, or it's extracted mass property information, moment of inertia, center of gravity, of all the parts that come into that, cross into that volume. And what we then do is generate a report for each one of those volume sections that is computed by Inertia 360. An example of the mass distribution report, you can see here volume 54, volume 55. So going back to my previous slides, all the parts that cross into those particular volumes, you get a breakdown of all the parts that do so, and then you get all the resulting information of the result part after the clippings have been created. Weight, center of gravity, moment of inertia, etc. A few of the other features of our software, Inertia 360, the ability to create difference reports. So if over time, as you do mass properties calculations, weight distribution over your assemblies, as they progress, you can store all of that information and you can generate difference reports to show you where weight differences could have occurred in different variations of the assembly. Configuration enables setting the densities of individual materials, so you have complete control over your CAT materials file. The one you have in-house is the one you use in our application. All reports are saved to an SQL database if that is the case for your particular company. It's not necessary. You can simply save this as your Excel file and save it locally to your machines or a homegrown interface or database. The ability to apply fasteners and sealants. Inertia 360 incorporates algorithms for approximating fasteners and sealants within the calculations. And we do currently have an interface with Inertia, can extract mass properties from Inertia and populate it with newly calculated values. So let me now go into a live demonstration of our software. So before I begin, what you'll notice here, this is the assembly we're going to run the analysis on the right-hand side here, this rear suspension. And what I have open on the left-hand side is our volume model, which we're going to use in this same example. So just to give you kind of a visual as to what's going on here, when I do get to the mass distribution section, basically I talked in my presentation about the different volume chunks or volume sections. This is how it works. So you take the overall assembly, and in our software what it does is it assembles it as you see right here, and it creates the section cuts for each one of the parts that come into each one of those sections specified by the designer. Close a couple of these windows. Okay, so to run our software very easily, simply double-clicking on it, an executable file, the interface pops up. You do not have to have CATIA V5 open. I, in this case, do, just to show you what's going on in the background. Again, the great thing about our software is that you do not need to be a CATIA V5 designer. You don't have to know anything about CATIA V5. So what you simply do is you launch the application. In our settings area, we have the ability to point to a materials file. So your company CAT materials file, this is where that's specified. And you can also see where you can set the coefficient variable for things such as fasteners, paint, and a sealant. So once that is set, we can then simply go and analyze for the weight of the object that we have open. So we can specify the CAT product which we're going to look at, or we can simply just use the active CAT product by selecting this icon. What we then do, or what our software then does, is it finds the running instance of CATIA V5, finds the open CAT product, and it then sets itself up to check for the materials that are applied to the parts within the CAT product. So what it'll simply do is check the materials within that assembly, and you can see it finds all the parts that make up the assembly we had specified. It also shows you the materials of each one of those parts. What you'll see on the right-hand side here is that CAT materials file, which I've pointed to in my settings interface. And at this point, if one of these parts were undefined, I can simply select and apply it to that particular part, and then run Inertia 360 for that material. What I can also do is push this back to the CATIA model if I chose to do so, so that undefined part or that undefined material in the part now has a defined material. Generating a materials report. So just to create an Excel file to document that information, just using our interface, Inertia 360, you can see here the report that it creates. Again, customizable depending on your company's requirements. But you can see the date today. You can see the breakdown of the CAT product we're looking at, the different subassemblies possibly, the components that make those subassemblies up, the components themselves, the next assembly, any other type of parameter that you chose to have pop up, the material and the density for that part. Now we're going to generate the weight report. So it's saving to a particular location. If we had a database connection to the Inertia 360 software, we would simply select this icon to push this information back into the specified database. If not, we'll just simply generate the weight report using the information we have so far. So again, Inertia 360 is doing all the work. CATIA V5 is simply open in the background. You'll see it flashing from time to time. When it's complete, this is a sample of what you get for the weight report. So again, just a little expanded on the previous materials report. We have all the information of the parts, the materials, the densities, the volume, the surface area, and then the unit mass of the entire CAT product based on all the densities applied via the material. So rather than having to, like I said, understand CATIA V5, having to open up the software, having to find an assembly, opening it up, how do I manipulate this thing? Where do I find the icon to extract this information? Is everything properly defined? How do I go into each part, make sure the materials are correct? All you simply have to do is run the executable, point to the top level CAT product, and then our software does all the work. It very clearly specifies the fact that a material is undefined. You then have the ability to very simply apply aluminum to that undefined material and then generate a report as you see right here. This report is then saved locally automatically in Excel file format, which you can then forward off to anybody that needs to see that document. Just opening up folder structure here, you can see the reports that I've just created have just been created in this folder that contains all the parts. Okay. Our mass distribution tool. What I'll do is I'll open up this folder here called clipped parts just to show you what's happening in the background when it goes through the analysis of the volume sections that I'm going to specify. Excuse me. So running the mass distributions report interface, again, I just start to fill in the blanks. So I simply point to the top level CAT product, and then point to the converted CAT product. What we're doing basically is, what you don't want to do, is manipulate an assembly or a project that has been created within your company that has taken you time to create. So instead of chopping up and possibly messing up things that have taken your company a long time to create, what we do is we take that CAT product file, convert it as a CAT part file, and then do all the cutting and chopping on that part, so it doesn't in any way affect any information that has been created by your designers. So what we're then doing is we're applying the material information from the master CAT product to the temporary CAT part, and then at that point doing all of our calculations for that converted model, saving you any possible problems in the future. Pointing to that volume section model, so let's just make sure that we are pointing to that volume model. And in this case, what you'll see, if I go to my set volume selection filter, if you recall the very first screenshot I showed you, I put that volume model over top of the assembly that we're analyzing. You can see, or if you recall, there was 8 sections. So to verify the fact that it sees the 8 sections, you can see in the interface sections 1 to 8. And knowing this now, if you had a large volume section model with, say, 500 different sections, and you were only concerned with a certain area of the assembly, you didn't have to go and do the analysis for the entire volume model. What you can simply do is select the different sections you want to do the analysis for. So for the case of this presentation, I'm just going to select the first 2 sections. And what you're also going to do is specify, in this case you can see my clip parts folder, rear suspension, clip parts, okay. And now if I generate my clip parts, what you'll see momentarily start to show up on the right hand side is the files that our software is creating within those different volumes, say in section 1 and 2. And you can also see CATIA V5 in the background going through a bunch of iterations and calculations and opening things up and chopping things up, all of which that you don't have to do. When this is complete, what I'll do is I'll generate my mass distributions report. You were shown an example of that or a sample of that in my PowerPoint presentation, how it gives you volume 54, volume 55, for example, and it shows you all the parts that cross into those particular volumes. And then it gives you the mass properties, the total weight of each one of those parts, moment of inertia, center of gravity of the overall volume, and each individual part. So one of the great things about our tool is that, in the case of a large assembly and a large amount of volumes, what you can do is you can run this analysis overnight, saving you the trouble from sitting there and having to watch it or do it manually, where you can just run the application, step away from your computer, and when you come back the next day, the report's been completed and the information has been populated back into your database, for example. When I do generate the mass distributions report, what it does is it does the calculations for the assembly's center of gravity. But what you can also do in our interface is you can specify a user-defined center of gravity. So in this case, I've just got the default set to 000, whereas it's not important for me to do that right now. But if I wanted to analyze around a specific center of gravity, along with the actual CAT product center of gravity, I can do so within our Inertia 360 interface. So you can see the parts so far that are being created. All the parts that are in section 1, we're now beginning to loop into section 2. And just bear with me one moment, we're almost complete with the 2 sections, and then we will complete our mass distribution report. Okay, we're almost done here. As you can see, this is a perfect opportunity to get up and get a cup of coffee, but we're almost done, and then I can finish off the report. The great thing is that the software gives you feedback, whereas we're progressing 96% through the analysis, so we're just about done here. Okay, perfect. So the calculation has been done for the first 2 sections there. What I'm going to do now is generate the mass distribution report. Let's just go in, let's just call it mass dist report. You can see all the parts that were created. If I just back out of here, I'm simply going to generate the mass distribution report. Let's just give it a title, Peter's report Tuesday, run 1, for example. I can pop in the date, generate the report, copy to the database if I choose to do so, and I'm going to open the report once it's complete. Okay, and here we have our report. So going into tab 1, Peter's report Tuesday, run 1, on the top level CAT part, inertia data taken about an axis located at the aircraft center of gravity. So volume 1 and volume 2, which I specified in the Inertia 360 interface, the weight of each one of those individual volumes, the weight of each one of those parts that cross into the volumes, just that piece, the center of gravity with respect to 000, moment of inertia. If I go to the next tab, in this case I didn't specify anything other than 000, so the center of gravities will be the exact same. Summary, total aircraft of the converted, or the calculated volumes, section 1 and section 2, the total weight, center of gravity of the total calculated volumes, and then some density information as well for the parts in each one of the volume sections. The difference report generator, so what you can see here when you activate this icon, when you're completed computing for mass distribution, for example, what you simply do is you specify the 2 reports and then you have it create the difference report showing you the difference in the specified areas of concern, the density, the total mass. You can track this information and you can track the changes as the assembly progresses through time. So that is basically the end of my presentation. If there are any questions, please feel free to type those in to the GoToMeeting interface there on the right-hand side of your screen. If you hit the orange little arrow, if you've got your tab minimized, just hit the orange little arrow and it expands for you, and there's a questions area there. If there's anything you'd like to ask at this point in time, please feel free to do so right now. If not, we can always get back to you at a later date and answer any questions that you may have. Here's some contact information that you can follow up with. If there's anything that should pop up at a later point in time. Okay. Thank you very much for joining us today. Once again, my name is Peter Jarkowitz. I'm an applications engineer with Mechanica Solutions. This was a presentation on Inertia 360, a software developed by us for CATIA V5. Again, anything that comes up in the future, please feel free to contact us via telephone or email. You can see that on the screen right there in front of you. Thank you very much for your time today.